So we have David Caldwell, who is from Public Health Scotland and is going to share some insights about developing reproducible analytical pipelines and tell us a bit more about that. And we have John Stevenson, who's from the British Geological Survey and is going to talk about how going open is not a process. I do apologise, is a process rather than an event. So I'm really looking forward to hearing from both those speakers. So I'm from PyData Edinburgh, so we've collaborated with the Edinburgh R group on the events this week. They are both Edinburgh-based meetup groups that happen, so we're all volunteers, we all give up our time to organise these types of events, and between us we have over 2,000 members that come along. I haven't done the data analysis for that. I don't know what our overlap is, so I don't know whether or not I've got 2,000 unique people there, but maybe I'll come back with that information later on in the week. We'll see how it goes anyway. But it just goes to show the amazing interest there is in this area, so we're really delighted by the speakers that have been able to come along and join us today. I'm going to pass over at this point to Greg to give you a bit of information about Matrix.
Thank you, Sam, and I'll echo everything you've just said there. Welcome to everybody. The interest in this is immense, and I'm going to riff slightly on John's talk here and talk about process. Process implies duration rather than a one-off, and I don't want this week to be a one-off. I want us to build a community. To that end, I don't want to lose the chat that's happening in Blue Jeans at the end of the session. I want it to live longer than that, for us to have meaningful chats longer than that. So we have a Matrix room. Matrix is an open source decentralized communications platform. There is a link in chat right now. You can also find it on the Coding in the Open website. Please do come and talk with us. Please do try and ask your questions there if you can, so that we can keep everything together over the course of the week. If you make a mistake, you put it into Blue Jeans, that's fine. I will copy it across so we can keep it all in one place. It's my job to keep those in sync this week because it's a bit of an unusual situation. But otherwise, please do come and join in. I'm hoping maybe this afternoon we can do some introductions and things now that we've got a sort of quorum of people on there and get to know each other a little bit better. But I'll not take up any more time from our excellent speakers. See you there.
Thanks very much, Greg. I would definitely echo that. We want to build more of a community. Both of our tech groups that we run are all about community and sharing our learnings and our understandings and the things that work for us and the things that don't work for us. And whether or not you're a speaker or you just want to ask questions and find out more about what other people are doing, building that community is really brilliant. So please join the Matrix conversation if you can. And if you aren't a member of the other group, if you're PyData Edinburgh and not Edinburgh R or vice versa, please feel free to join the groups and you'll be able to keep an eye on other speakers as we go through the year and about what you might want to attend and listen to as well. So I'm going to stop talking at this point because you didn't come to hear me talk, and I'm going to pass on to our first speaker, who is David Caldwell. So David, I will hand over to you.
Thank you very much. Hold on, let me just share my screen, get my slides up. Right, so I'm David Caldwell and I am a Principal Analyst in Public Health Scotland, and today I wanted to talk to you a bit about our experience with developing reproducible analytical pipelines using open source and how we have tried to do this in an open and sort of transparent way. The slides that I have put together today are available on GitHub here at that link, so we can maybe share that with people after I'm finished speaking. I'll just give you a bit of background on Public Health Scotland and who we are. So we are the sort of main official statistics producer for the NHS in Scotland, and we produce around 200 official and national statistics publications each year. The sort of traditional publication output is a static PDF document with accompanying Excel tables, and these are usually produced using proprietary software, primarily SPSS, although not exclusively so. Here I've got a little illustration of how the sort of traditional publication process would look like. So you would have your data store, and then your data would be extracted using SPSS, multiple SPSS scripts. And what you would output from SPSS is separate sort of Excel files. And then usually around that point, or even later when this is all pulled together into the Microsoft Word version of the full report, that's when the quality assurance would happen. And if there were any issues around queuing of the data, you would have to go back to the start and start again. So in general, this sort of process was quite complex. There's a lot of steps. It's prone to error because there's a lot of manual steps. There's lots of copy and pasting between Excel files, your CSV output to the .xls formatted output. Quite menial and a dull task, to be honest, which has been carried out by sort of highly skilled people. And there's lots of easy things to miss. Like one of the most common mistakes that's made when updating the Microsoft Word document for a regular publication is things like the publication date. If you do it regularly, that's the sort of thing that's very easy to just gloss over and not realise needs to change. So there was lots of scope for things to go wrong with this process, and of course it was not reproducible or sustainable for these reasons. So, what is the solution? I don't know if any of you or how many of you have heard about RAP or what it is, but essentially it is combining the principles of reproducible research with data science tools and best practices. And it was thought up by these two guys here. We call them the two Matts, Matt Upson and Matt Gregory. They are civil servants, and I think it was originally the Department for Education, but they've moved on somewhere else. But they are UK government civil servants. And essentially, one of the sort of basic principles of RAP is to use open source software for the entire production process, or for as much of the production process as possible. And that's from the initial data extraction to the final output. So it's using open software, ideally code, to do the whole thing, in essence automating it. So some more detail on what a RAP project is. So an ideal RAP project would have absolutely no manual steps at all. So the data and the output would all be produced using code, although there is a recognition that that's not always possible, and that there will sometimes be a need for a human to do something, whether it's click a button or actually check that the output has run and looks as expected. A RAP project is high quality and auditable, because another one of the sort of main principles of a RAP project is that the code is version controlled. So we do this using Git and GitHub, and that ensures the quality because it ensures peer reviewing, which leads me on to the sustainability. So you can really have that confidence that the code is well written, it's good and robust, and does the job as expected. And part of that is having the code available on GitHub or other sort of code sharing platforms, but we primarily use GitHub. And I've got here the bells and whistles. So a full RAP project, as we call it in PHS, is a bespoke R package. It doesn't need to be R, but that's our primary tool, which has functions to do everything. All of the functions are documented, are rigorously tested. And these last two things, package management and computing environment, are still ambitions for us at PHS. We've not quite managed to get Docker rolled out to the analytical workforce, but that is the sort of final step of making it fully reproducible. As I say, that's still an end goal for us, but you can do a full RAP without it. So here is another illustration of what the process looks like for a RAP project. This may look on the surface a bit more complicated, but it's a lot more straightforward for the user to do. Effectively, you'll have R functions to do all of the data wrangling, so that the functions will extract the data, manipulate it as appropriate, and then output something called the minimal tidy dataset. The minimal tidy dataset is just a fancy way of saying the minimal amount of data that is required to produce the final output. So that could be a CSV with numbers, or CSV with numbers plus any other sort of supplementary information that's needed to update things like the full report or the Excel tables or that kind of thing. But the minimal tidy dataset itself is then put through another series of R functions, which then outputs the final output, which under the sort of traditional PHS approach is a PDF document, but doesn't necessarily have to be that. So we use R and RStudio and primarily the sort of tidyverse suite of packages for the data wrangling side of things. And for the automating the report, again, we use R Markdown for that. All of this code should be version controlled using Git and on GitHub. And our Public Health Scotland GitHub page has Travis CI enabled. So if people want to use continuous integration to be even more rigorous with their testing of their code, that's available to them as well. And peer reviewing of all of this should happen as a matter of course with using GitHub. So here I've got a table of levels of RAP. So this came about because there's a recognition within PHS that there's no one-size-fits-all approach to doing RAP, which can come about for a number of reasons. It could come about due to skill levels and the teams that you're working with, or it could come about due to just the specific needs of a particular project. So how far a RAP project needs to go in terms of the all sing and all dance and bells and whistles our package is very much dependent on those things. But when my team is working with other teams to develop RAP projects with them, we recommend a minimum level 4, 4A or 4B, which ensures that the project is version controlled and that there is a replicable report produced in our Markdown or equivalent. Analysts don't need to go beyond that. It would be good if they did, but we would recommend level 4 as a starting point. And if anyone looks at these slides later, this title is a hyperlink to a full paper that PHS published on our old ISD website a couple of years ago, which has a lot more information on RAP and our sort of general approach to it. So if you're interested, you can take a look at that. So next, I want to talk about a case study for how we went about implementing RAP in PHS. So we started with a proof of concept, which was in the form of the Hospital Standardised Mortality Ratios publication, which is released quarterly. This publication at the time was a 40-page publication document. It had a 2-page publication summary, and at the time it had 7 Excel tables. The output now is down to 3 Excel tables, but originally it was 7. So our aim with this case study was, as I said, to prove the concept. So we wanted to do that and also teach ourselves the principles of RAP so that these skills could then be spread to other teams in the organisation and we could work with them. And not just with other teams in the organisation, we wanted to spread that good practice and learning that we've picked up with other public sector organisations in Scotland. So we've shared learning with Scottish Government and UK Government colleagues, as well as other public bodies. This proof of concept did not involve changing the output beyond the reduction in Excel tables from 7 to 3. That was just an efficiency thing rather than actually wanting to make a change to what the publication was presenting at the end of it. So all the code for this is open, publicly available on GitHub. Here is the link here. If you want to take a look at it, feel free. We have shown this to a lot of people over the last couple of years, and it's been really, really helpful having it public because it's been beneficial to other teams within PHS because they've been able to look at the sort of high quality of code that's in this repository and borrow it and use it or repurpose it for their own needs. But it has also been helpful for external colleagues who have taken a look at it and might have had some suggestions for things to improve. So that's been really, really helpful. So the finished product was a bespoke R package which contained minimum 17 bespoke functions. I think it's actually we've got another couple that have been added since that carry all of the tasks which are repeated each quarterly cycle. So that's everything from the data extraction through to the spitting out a publication report and all the Excel tables at the end. Each of those functions has comprehensive error handling and are rigorously unit tested to ensure the quality and accuracy of the data. And it automates the whole entire process from start to finish. And as we were going, the output was checked regularly against the original SPSS process, just to ensure the accuracy, but that was also to provide some confidence to the team who had ownership of this, because they were at the time a little bit unsure of using R and they were very comfortable with SPSS. So that was a helpful bit of work for them to see that the output was providing the same output and it was producing the same numbers. This was first released on the 13th of August 2019, and this link will take you to the publication page at the time, just so you can see how it looked like in 2019, although we now have a new website because we're Public Health Scotland, we're not ISD anymore. But the publication itself hasn't changed, and all of the content is still there. So what are some of the benefits that we have experienced just with this HSMR publication? So the processing time for this publication was previously about a week of solid analytical time. That included updating the SPSS scripts every quarter, running them, checking the output, manually updating the Excel tables, manually updating the publication report, and then all of the checking time for other analysts to do an independent review to ensure that everything had been done accurately. It took a good solid week. But we've managed to get that down to under an hour using RAP. And that's the whole thing. You press a button, go make a cup of tea, and by the time you're finished your cup of tea, the publication report has been produced and has been updated, and there's generally no further requirement for the analyst to do anything after that point, other than obviously look over and make sure that it hasn't input some error code in the Word document at the end, because that would be embarrassing if that was published. Another benefit is there's a higher quality of code. This comes about due to the sort of rigorous error handling and unit testing and all that sort of stuff, and the peer reviewing that comes about from using version control and using GitHub to do that. And I can also say that in the process of developing this in R, we did find a couple of very small, very minor errors in the original SPSS syntax. So it was a good exercise to catch those and fix them. Better workflow practices are now employed by the team, which again comes about from them using version control. Though no changes are made to the code for this publication without it being reviewed by another analyst, just to ensure that code is doing what it should be doing, that there's confidence in the accuracy of the code, and that the output is accurate. And for me, this is one of the most important things. There's an increased enthusiasm and excitement from the team now when they do this publication, because it's actually interesting to them now. You know, these are highly skilled, highly technical people, and they like this sort of thing. And they don't really enjoy copying and pasting between Excel workbooks and manually retyping dates and numbers in a Word document. At least that's been my experience. In terms of the outlook for this, more time has been freed up by the team because of this more efficient process. So they have more time to pursue more interesting pieces of work, and they have already begun work on implementing some sort of supplementary output into the RAP process. So that includes things like open data. Currently, there's no open data produced for HSMR, but the idea that we have with RAP now is that open data should fall out of it as a sort of byproduct. So they're looking into adding that. And there's also more time for exploratory analysis into improvement. So again, more information on HSMR. It's a publication that has undergone full reviews a couple of times over the last 6 or so years. And that's very time consuming to do. So now that not so much time is dedicated to the publication process. Whenever it comes around, the team will have more time to dedicate to those sorts of things. So after the concept was proved, we began to roll RAP out to other teams in Public Health Scotland using what we call a buddy system. So how that works is one or two members of my team will sort of buddy up with another team that has a regularly released publication and helps them develop a reproducible analytical pipeline. So in practice, the team that my team works with will do the work themselves, but they will have someone from my team to act as a sort of guiding hand for them and be there to sort of help out where needed. And all of this is or should be done using Git and version control, and all of the RAP code should be on GitHub or within our Git server, which is our sort of internal version control platform. And as I said before, we recommend teams aim for a minimum of level 4, A or B or both, which is laid out in that RAP paper, which I mentioned previously. And just a little bit of an illustration of how things have progressed. This is not exhaustive by any means, more publications have been done, but I think this just neatly illustrates how the process can evolve. So the test case started with myself and another analyst, and we taught ourselves all of these skills, and then we moved on to these other two publications, the bill screening publication and end of life. And then once those skills had been spread in those publications, we were able to spread them further into those other publications you see there at the end. So it's been a really, really, really good piece of work for the whole organisation, and I can definitely see a difference in confidence and enthusiasm with using something like R to do our sort of the bulk of our data wrangling in our publications. People are really interested in doing it now, and that's a stark change on where things were a few years ago when we first started. So just to wrap things up, I have a couple of links here. You can email me or email my team if you have any questions, or you can take, well, my personal GitHub doesn't really have much on it, but the Public Health Scotland one has all of our publicly available code there for you to take a look at, and we have a lot of projects. So maybe see if I can show you quickly. I'll stop and then start sharing again. So we have a lot of various different projects that are version controlled in or on GitHub, and all of that code is open and available to anyone within PHS or outside to make use of or help improve. So yeah, that's me. I'll stop talking now, and if anyone has any questions, I'm happy to attempt to answer.
That's brilliant. Thank you so much, David. We're actually going to keep questions. We've got some great questions actually have come in on the chat. We're going to keep questions till the end after both speakers have spoken, if that's okay. Really interesting, definitely areas close to my own heart in terms of some of the topics you've brought up. So I was fascinated to hear that. Thanks so much. Yeah, keep the questions coming in. They're popping up. Some are onto chat, which is really brilliant, and some are going into Matrix. We'll be coordinating them all over there. So keep adding them in, and we'll ask them as we get through with whatever time we've got left after we've heard from our second speaker, who, yeah, I'm delighted to hand over now to John Stevenson, who is a research software engineer with the British Geological Survey. Seems to have a liking for volcanoes in Iceland, but I'm not sure whether or not we're going to hear anything about that today. So I will hand it over to you, John.
Yeah, thanks, Sam. So, yeah, I'm a senior software developer at the British Geological Survey, and I've been there for about 4 years. And prior to that, I was an academic and a geologist and a volcanologist. So that's where the volcano interest comes from. And in my talk today, I want to talk about going open as being a process. So it's not something that happens overnight. It takes a long time. And so I want to kind of give some examples of where we are with this process at BGS, and some of the things I think that you can put to help you move along in it. So, to click in the right window, there we go. So the British Geological Survey is the public sector organisation. We're civil servants, and our mission is to provide impartial and independent geoscience advice and data. And so we work with academics, governments, industry and the public. And our bgs.ac UK is an academic email address. There's a lot of research work, some commercial contracts and some public surveying work as well. We've got a long history already, at least 10 years, of our digital division of making digital data available. So the One Geology portal and the Open Geoscience portal, it's been possible to go and download a geological map of the UK or get information about boreholes into the ground, scans of maps, photos of rock types, things like that, for over a decade now. And also we're quite big contributors to ways of sharing data, for example, APIs for making data available and standards such as GeoSciML, which is a markup language for sharing data about rocks. As an organisation, there's about 650 people, of which 70 are in the digital division. And that includes professional software developers and database experts as well. And then we've also got a lot of scientists. So this means we've got this pool of people who already know about coding in the organisation. So in terms of going open, for BGS, we've got some kind of headwinds that would slow us down. So going open can be hindered by previous investment and skills in proprietary technology, by siloed confidential data and requirements of security standard certifications. To build on these, the investment and skills, BGS has always been quite forward-looking, but that means that when they invested in a load of stuff 15 years ago, before a lot of the open source tools were as mature as they are now, we've got a lot of equipment based on Oracle databases and Esri and ArcGIS map things. So all these proprietary tools that were the standard back then. And that can mean it's hard to move on because they all work and they're working fairly well. So it's hard to encourage people to move on. And that kind of makes you think a little bit about countries where in the old days everyone was putting in telephones and everyone laid down copper cables all across their countries and had pylons, and nowadays you would just go straight to a mobile phone, and it's just kind of the same. If you were starting now, you would go straight to the open source, but we've got this legacy stuff that's still pretty good, so we have to work with that. We've got lots of confidential data, and it's all siloed. At the moment we don't have any cloud infrastructure, everything is self-hosted. And that can make it difficult to go open because it can be hard to get the data to the code and vice versa. So that can be a bit of a hindrance. Then there's also requirements of security standard certifications. So we do work, for example, with the Nuclear Authority interested in storage of nuclear waste. And they've got very high security standards you have to stick to. And so they're a bit worried about open source software, and there was a spate a while back of supply chain attacks where open source packages were getting hijacked and fed with Bitcoin miners and things like that. So we've got to be wary that some people are reluctant, security team are reluctant to go wholeheartedly unless we can mitigate some of that kind of stuff. On the other hand, we've got some good tailwinds as well. So going open is helped by projects with external partners, by scientists adopting reproducible workflows, and by supportive senior management. A lot of our work is with overseas partners. We did a lot of our funding comes from overseas development agency. We do work in Kyrgyzstan, Tajikistan, Uganda, Kenya, places like that, helping people and geological surveys over there get set up. And they don't really have access to these expensive proprietary tools. So in learning how to use open source software so we can work with them, we get the benefit of being able to use it ourselves too. We've got another angle outside of software. We've got the scientists and the movement within science that people who publish papers are now encouraged not only to publish the data but also the code behind it. So scientists are interested in adopting this kind of stuff. And there's always been supportive senior management. This is important because this kind of change, it doesn't come from the top down, it comes from the middle. So adoption of these technologies is really being driven by the senior developer level because these are the people that are using the code every day, and they know how it works, and they know the advantages and disadvantages, and they can see that, and they can try and then persuade the senior management that this is what we need to do, and ask for money when we need to buy things, and they've been supportive about that so far. And again, with this general forward-looking outlook, and a few years ago they made a point of hiring senior developers who explicitly said they were interested in open source and things. So they're kind of interested in moving us forward in that way. Now, this talk then, and the coding in the open, I've kind of went away and reread that blog post on the Government Digital Services website about the benefits of coding in the open when I was thinking about this session and the talk. And when I read it, I kind of realized actually it's kind of like one-dimensional, because it's talking about the openness. And actually for coding in the open, there's two dimensions. There's the openness aspect, but there's also the codingness aspect. And so I think that post was basically written for software developers who were probably using open source anyway, like JavaScript libraries, and telling them about the benefits that they could have if they can open their source up. When you look at it in the scale of a wider organization like BGS, though, then we've also got people who are not writing code at all. And there's an aspect of encouraging them to write code as well. And we've talked about in the previous talk and other sessions that the more you use code, the more reproducible work you can do. Some of the Software Sustainability Institute literature, they talk about people who write code and people who write papers or reports, and the spectrum in between. And we've got all of them. We've got software developers, and our analysts or our geologists. And then the people who are in between are these research software engineers. So we've got to span that whole spectrum. And then we've got the openness angle. So at the bottom, there's the proprietary tools. And as you've got that dimension, you can be using open source tools, but not sharing the code. And then finally, there's open source and open code. And I think the benefit of this aspect is the portability. Because once you've shared the code up there, anyone can use it. And if it's got open source components, then you can install them and run them anywhere. So the portability is amazing. We had a great benefit of that at the start of the pandemic when people started working from home, and took a while, everyone getting organized with VPNs and stuff. And people could just work on our open source projects because they could do them from anywhere. So that was pretty nice. Okay, so the question that we want to ask then is, if you're working down here, how do you get yourself up to the open source, open code kind of area? I think the most important thing for this is training. And as was talked in Kirsty's talk yesterday, Git is central to everything. So as a developer, you need it for storing your code, but all of the interaction tools, the issue trackers, the bug lists, everything is Git and GitHub or GitLab. So as an organization coming to this from scratch, the most important thing you can do is Git training. If you want to move people along to the right, get people towards the research software engineer end, then you have to teach them to code. You can teach them Python or R for their scripting. But what we've found is that can only get you so far. And actually, if you want to get even better and higher levels of coding, the way we've found it's good to do that is to do pair programming, which is a bit like the buddy system referred to in the previous talk. And that's good for teaching people things like how to do tests and set up continuous integration and stuff. So this is our process. It takes time. We installed GitLab internally in 2016. So that is a self-hosted equivalent of GitHub. It does all the same things. Issues and things, got excellent continuous integration. Git training began in 2016 and started with developers who were previously doing SVN and then spread from there. We started running Python clinics in 2018. These are every fortnight. People can come along with their laptops at lunchtime, and there's developers there, and you can sit down and you can get help with your code so that you can share experience that way. And then we started doing GitLab project management training, teaching people how to do the issues. And that also included some continuous integration stuff so people could see the benefit of automated tests. We've been teaching people to code with the Python training. The Python training and the Git training are both based on the software carpentry lessons. And we've also recently started doing a Python improvers training course as well to get people writing more professional code. Okay, so this then is where you kind of were about 5 years ago, where we were mainly on proprietary tools and our code was mainly internal. So the analysts are using Excel, ArcGIS, ER Studio for creating database layouts. People are doing some scripting, ArcPy and MATLAB, for example, IDL for remote sense data. And the developers are doing things like writing Cold Fusion APIs so people can get data out of Oracle. And the questions about how do you get from there up to the open source? Well, I think two of the important things are to give people hands-on experience. And the reason for that is that the open source tools now are so good. So QGIS for GIS and making maps, Postgres is a database, Pandas for manipulating data. They're just so good that if people get a chance to use them, they'll see the benefits for themselves. And then the other aspect is getting corporate buy-in. So you've got to convince the higher levels of management that people are getting benefit from this, and you've also got to figure out ways that you can deal with worries about security and things like that. So in terms of a timeline, again, this stuff has taken a while. So if you go back to 2017, 4 years ago, the network infrastructure IT group set up a separate area for developers to work in where we could install whatever packages we want without worrying so much about the security controls that other things had. By 2018, GitLab had taken off so much that we were able to persuade the management to fund GitLab Enterprise Edition. So this comes with extra things like off-site backups and security features like scanning of Docker containers. In the summer of 2019, there was a digital workshop, and we managed to arrange a session and a keynote speech about open and reproducible science. This was done by Caroline Jay from the Software Sustainability Institute, and her talk, we recorded it, it's on YouTube, so you can watch it there. We sponsored a GIS conference, and then most recent digital strategy on the back of that workshop now has a section explicitly on collaborative, open and reproducible research. So it takes time for that kind of stuff to come through. And now most recently, we've had Nexus Firewall approved. This is a server that you can set up that is a local repository for Python and R packages. And what it means is that it intercepts your requests and you pull from a locally cached version which has been scanned for vulnerabilities. So that helps keep the security team happy. So that gets you up to this branch here, and this is where a lot of BGS are working now. So as I was saying, QGIS, Postgres, Pandas are all excellent. We've got people using all of these. The software developer end, we've got some of our big projects now, our kind of new flagship projects are using open source tools and open source code. We've got the European Plate Observing System. This is a cross-European collaboration with different geological surveys, and that's all built in a collaborative way, codes in GitHub, application deployed by Docker, everything like that. And we've got Sensor Things API, which is going to be how we're going to share sensor data, and that's based on Frost Server, which is an open source API tool, and that's backed by a Postgres database. So these things are coming, and this is where a lot of BGS stuff is working, and it works quite well. And actually, keeping the code near the data. If we're going to deploy internally, it's kind of handy to have the code internally. Then that stuff works quite well. But it is nice if we can to get up the next step and get up into fully opening everything. To do that, you've got a couple of things you can do. First of all, you've got to get over impostor syndrome. Everyone worries that when they put their code out, it's not going to be good enough, and people are going to see bugs, whatever. You just have to get over that. Persuade people that that it's okay. For scientists, it's really helpful if we get developers to have a look over their code because they can tidy it up and make them feel a lot happier with it. And then the other thing, again, this idea of separating the code from the data, is if you extract common libraries for things that you do all the time and code that you would otherwise be sharing amongst yourselves, you can extract that and you can share that, and then that becomes a public contribution. So in terms of a timeline of releasing open code, we're not new to this in BGS in that we've been contributing to open source projects for over a decade. So Map Server has Inspire capabilities, and we've got multiple contributions to GeoServer going back for years. But the bigger turnaround was in the summer of 2018 when we actually got a GitHub presence. And we decided to get a presence on GitHub because it's wider known, more people use it, and that's where we put our code. So I'll just give you a run through some of the packages that are on there. Some highlights. There's one on viewing geotagged photos in QGIS. This is notable because it doesn't really have any code. This is actually just a how-to. So that's an important thing. You can put your documentation up there. If you're going to explain it to people internally, why not just explain it to the whole world? We've got Etl Helper, which is a tool we wrote for transferring data between databases. That's good. That was an internal library. We've got the GeoNER model. This is interesting because this is one that came out of an academic paper. So this is the first time we've published code along with a paper. And this is a tool that can read text and can extract the names of rock formations from the text based on machine learning. Last year we released Dissolve, which is a tool for groundwater modelling and borehole testing. That was also to support a paper, and what's nice about that one is it also came as a Python package that people can install with pip. And then most recently, Stratigraph is interesting because it's the first one that we've made that was open source from the start. So it went right up to GitHub to begin with. And that's a kind of experimental tool that can read text about different rock stratigraphy layers, and it can figure out their relative ages, and then it can create a graph of where they all sit one above the other. So that's a pretty nice project. So this is where we are in BGS now. We have got code on our GitHub repo that is in all of these different locations. Okay, so in conclusion, it's Git training, Git training, Git training, and Git training. That's what you need if you want to go open. Well, it's not really. It's Git training and coding training and pair programming to get your programming up. In terms of getting corporate mindset, then you should listen to the security concerns, and there are ways to mitigate them. And so you can do that. The best way to get people into open source is to give them hands-on experience. So if you can find an independent project that you can do it on, then that's a good way to do it. And in terms of publishing your more developed code, then a way that you can get stuff out there is you can extract things that do commonly and put them into reusable libraries, and then they can be shared. So Sam, how am I doing for time?
You're doing very well for time. You're going to ask if you can have your extra 5 minutes. How about we compromise and make it an extra 3 minutes, because we've got a lot of questions coming in, so I think it would be nice to get onto the Q&A. So do you think you can do your little extra bit in 3 minutes?
Yes, I can. Right.
I'm going to be generous and give you 3, but we have got lots of questions and it would be nice to get onto them.
Okay. So here's some bonus slides. There are more other ones, but I'll show you the one to talk about Etl Helper. So Etl Helper is our Python package that we released for simplifying data transfer between databases. And it was born because it was a pain to install the Oracle libraries into Linux. And Joe Walsh wrote a script that would do that automatically. And then from there, we found that writing a query in Python for the database was very repetitive. So we simplified all that boilerplate out and put it into this package. And so the idea is that we can have people who've only done 1 day of Python training and only just beginning to use Python can get data in and out of the database quite easily. So I'll just give you a quick look at a GIF of how it works. And if anyone's using Python with databases, they might be interested. So first of all, you have to put your password into an environment variable like that. And you can define your databases. with the standard connection parameters. You can put that in a package. Then if we show how the queries work, so we have a couple of functions that are useful, like get rows and copy rows. And you import your databases, and then you can create your connection. And now if you want to get data out of your database, you can just call get rows against the connection. And there you go. And the data come out as named tuples, which mean you can access them by field name. And this wasn't too hard to begin with, but it's just even easier now. You can also connect to a second database, and we can see here that the exported table is empty. And then you can write a query that selects data, and you can write another query that inserts data, and then we'll get some logging so you can see what happens. But you call copy rows, and you give it the select query against the first, the insert against the second, and you can see that the data have gone across. So there we go. I'll stop there then, Sam.
Well done. I think that was almost bang on 3 minutes. That was great. Thank you so much. And it's always nice to see a bit of code actually in these talks. So that's really brilliant. Thank you. That's really interesting. And you've definitely hit a nerve with quite a few points that have come up, because again, there's been lots of questions kind of coming in. So the organisation team snuck in at the beginning and started putting in lots of questions, so don't take it personally. I'm just going to ignore those ones for now and scoot on to our audience questions. I'm going to start with one from Rambling Rivet. I'm sorry, I don't have a real name to go with that, but hello Rambling Rivet. Because it's a topic that's actually come up in a slightly different way, but in a few questions. So the original question was to you, David, so I'll start there. Was it difficult to get buy-in from people in the organisation for changes to workflow and to publishing using GitHub? And if so, how did you overcome it?
Yes, very difficult. That's probably been one of the biggest challenges that we've had, is the culture. And it's not something that we've fully overcome yet, but the approach that we've taken, which has worked for us, is get buy-in from senior people first, which was in itself a challenge. But once we got that buy-in from senior people, which we did by demonstrating primarily the time-saving benefits, because managers tend to think in terms of money, and that was a big selling point. Once we got the buy-in from them, the sort of awareness of what we were doing spread quite quickly, because they were filtering it down to sort of middle management level. And so when we were sort of looking for candidates for who to approach next, there were people who were quite enthusiastic. So we focused on the people who wanted to do RAP, and we are approaching what I think is going to be a sort of critical mass, where the people who are resistant to it will realise they need to get on board or be left behind.
So you highlighted there about that sort of senior management buy-in. That has come in from a couple of folk in a slightly different form, from James and Conrad as well. It also came in relation to your work, John. So can I put this question to you about that kind of corporate buy-in? How do you get that senior management buy-in to these changes and the processes that you want to do?
Yeah, well, that's definitely the thing that has taken time. And so we have got this big benefit that we've got these overseas projects where we have to use the open source stuff. So that's really nice in that there's not any argument about that. But what's been good from that is that then gives us demonstrations of how it works and how it can work very well. So that's come there. There is like a wider kind of management level discussions about trends in digital futures and stuff, and open source is now appearing on those things, so people are kind of picking up on that. But it has basically been the senior developers just talking to the level above them and trying to push it up that way, that it's gone mainly. Yeah.
I'm going to press on then, because we do have quite a lot of questions. If we don't get through them all, I'd encourage you to join up again in the Matrix group so we can get some answers to some of the other questions there if you want to. I'm going to jump to one that came from Tamora. There was a couple of questions that David has answered in the chat, so I'm not going to call them out loud at the moment. So if I jump to the question what Tamora said, David, about periodic reports are an ideal use case for reproducible reports / literate programming. How have you found the process of going back to a RAP project to produce a new report? Any issues with workflow due to changes in data or changes in R packages, etc.?
Going back to a RAP project to produce a new report in terms of something that's not periodic, or moving on to a new report?
I'm not quite clear. Tamora, if you're there and you can give us any more details around what that question meant, that would be really, really helpful. If you're still with us, you could unmute yourself as well and ask.
I meant the periodic report. So say it was an annual report and you came back the next year to do it.
I see what you mean.
Something might change in the meantime, and has that caused any problems for you?
So we haven't had any show-stopping issues that have happened as a result of changes, but the teams who we've worked with up till now and have developed the RAP projects have done the development themselves with us as a sort of guiding hand, using the sort of paired programming / buddying approach. So part of our aims with working with them to do the initial development is to skill them up so that they can deal with these issues if they crop up. So if there is a change, such as a change to a dataset, or they need a new table or whatever, the teams should be equipped to deal with that in the interim period and make sure that they've updated their code appropriately. But we do provide sort of aftercare, for want of a better way of putting it. So if such an issue did come up and a team was struggling, they could come to us and we would be able to help out.
Brilliant. I think we'll probably have time for one more question, maybe John, so I'll put one to you. We had a question from Nick, which was about the comparison between GitLab and GitHub. So specifically, did your organisation use GitLab because they could do a local install?
Yes. So the local install was the reason for GitLab initially, and it's very nice. It's very simple to install locally, and we ran it for we ran it for a year, and more and more people came onto it. It's all similar things to GitHub in terms of issues and pull requests and everything like that. It works just the same. It's also got really nice continuous integration features. So it's got GitLab pages like the GitHub pages, and it has these GitLab runners where you can do continuous integration pipelines, so you can you can run your code automatically in there and build Docker containers. It comes with a Docker registry, so you can store your Docker containers for sharing internally. It now has package sharing tools as well, so you can share your packages. So it is just really, really nice. And I think partly it's so nice that's one of the reasons why there's not more stuff going online, because we've got a lot of what we need in there. And if we're deploying to things that are internal, then deploying from the internal instances is quite easy. It also has code mirroring too. So Etl Helper, which is developed in the open, but it has integration tests that need to run against the Oracle database. And so you can set the repository up to mirror, and when someone pushes code and merges it on the GitLab, then on the GitHub, then it runs on the GitLab internally through the mirroring. So we started because it was useful for internal, and we keep it and we're happy with it. And it's mainly because GitHub has got like a bigger presence that we have our open stuff on there.
That's brilliant. Thank you so much. Right, so apologies. We're going to have to call a halt with the questions there. There's a few more there, but thank you for those that we got some written answers to as well. And yeah, go and join the Matrix chat if you want to follow up at all with our speakers. Who it would be great if you're not already there. If you feel like joining the Matrix group as well, and you can follow up on anything with folk. I just want to highlight who we've got tomorrow as speakers, because another great couple of speakers tomorrow. We've got Hilary Jum, who is a community manager with Mozilla, so that'll be a really fascinating talk, and Arfin Smith, who is a staff product manager with GitHub. So again, really interesting. We're running at the same time tomorrow. We'd love to have you come and join us again, so please do feel free to grab your cup of tea, grab your lunch, whatever you've been doing, and come and join us. David, John, brilliant talks. Thank you so much for joining us. They were really, really interesting, and clearly everyone is really interested in the topics you talked about, because we're just getting endless chat going on. You might not have been able to keep up with it yourselves at this point, but really brilliant stuff. So thank you all. Thanks again to everyone who's organising things behind the scenes and making all this happen. To Red Hat, who have essentially allowed us to be able to use the Blue Jeans instance we're using. All our community groups are supported by our sponsors that we run, so it's really important that they get a shout out for the good work that they do for us and everything. And thanks for joining us, and please enjoy the rest of your day, and we hope you come back and join us again tomorrow at 1 o'clock. Thanks again.